All right, welcome to TensorFlow.js, the Layers API tutorial part 2. So, previously on TensorFlow.js, Layers API part 1, I created this model using tf.sequential, tf.layers, and model.compile with a loss function and an optimizer. Now, let's just review that really quickly before I go on to the next step, which is looking at fit and predict. So I'm going to add some comments. Thank you to the chat just suggested that. So this is the model. Create the hidden layer. Add the layer. And the hidden layer has a number of nodes, input shape, and an activation function, which I think is probably pretty self-explanatory. Then the output layer, and it's a dense layer. So dense is a fully connected layer. Then create an output layer, create another layer, and here, I'm going to write here, the input shape is inferred from the previous layer. Then an optimizer using gradient descent. I must have a video somewhere that talks about what gradient descent is, if that's not familiar to you. And then I'm done configuring the model. So compile it. I don't know if this tutorial should have included me writing all these comments, but it did. So that's where we are. So in a sort of standard or sort of classic machine learning process, I would configure my model. And actually, before I do any of this, I should have collected my data and been really thoughtful about that and thought about the ethics of it and why am I doing this in the first place? And is this going to help people or hurt people? I should have been doing all of that. But here I'm just looking at TensorFlow.js as an API, so I'm kind of skipping those really fundamental, the most important parts. I'm doing things backwards in a way. And I'm just going to make up data. So what I want to do is there's two things. One is I want to train the model. I want it to adjust all of its weights to fit my training data. I have these inputs with these known outputs. Maybe I'm doing image classification. I have all these labeled images, cats, dogs, turtles. And I want the model to output cats, dogs, or turtles, some probability values based on which things it thinks that are. And then, so that's what this fit function does. I can also ask it to do predict, which means just take this data, I don't know what it is, this is not part of my training data, and just give me the output. So let's do something weird. I mean, weirder than what I'm already doing, which is talking to myself in a room with a camera and some lights. I have like an iPad with weird stupid sound effects on it. I don't know what's happened to me in my life. Anyway, let's run predict without having trained the model. Will it actually just, what does it start with? It must have a whole bunch of randomly configured weights, right? It must be configure itself randomly. Let's see if we can get some output. So what do I need to do to call predict? Let's go look at the API. And let's look at, again, tf sequential. So I'm looking for the predict function. Now here's the thing. The predict function is there. So it generates output predictions for the input samples. Model.predict. Okay, so config. There are some configuration options. Like batch size and how verbose I want it to be. But really all I need are the x's. The x's are the inputs, and I need 2 of them. So what I'm going to do is I'm going to create a tensor. I am going to say let input, or I'm going to say const inputs equals tf tensor 1d, and let's just give it some numbers like 0.5, 0.25, 0.25, 0.93. So 92. So I just made up some inputs. These are and all fake, not real data at all. I'm just trying to look at how TensorFlow.js, the Layers API works. So now I should be able to say model.predict inputs. Now let's go back and look at this. Model.predict tf1s. Oh, interesting. Nope. I guess I'm good. Okay, so hold on. So let's say let outputs equal model.predict inputs and outputs.print. I don't know. Could it really be as simple as that? Let's see. And so now, I'm going to go back here. Uncaught. Expected dense input to have 2 dimensions, but got array with shape 2. Oh boy, I think I might have a big major mistake here. All right, so what is this error? Oh boy, this is the kind of error you're going to get a lot, which is something is wrong with my shape. Shape errors, error when checking, expected dense 1 input to have 2 dimensions, but got array with shape 2. What is wrong here? I mean, after all, there are just 2 inputs. I said very specifically that the input shape is 1-dimensional with 2 things in it. So why is this wrong? Well, it turns out I forgot about this idea of batching. So it is quite uncommon, or it is possible that you just want to send in a single data point, like these 2 numbers in and get the prediction. And so even though this is the array of the inputs, that needs to live in an array itself because I might want to send in multiple sets of them. And so actually the correct way for me to put this here is to actually have this be the first element in an array. And actually this is not a 1D tensor then, it's a 2D tensor. So now if I run this, we should see, there we go, these are the outputs. And we can see here, every time I run it, I'm going to get different outputs because this particular model is initialized randomly. Now there's probably a way with the Layers API that I could configure how the weights are initialized, but it's using some default, probably random, maybe it's a normalized distribution of random numbers, who knows? We could look up in the documentation, somebody in the comments will tell me. Okay, so, but what's interesting about this is now, right, I could have, right? I could now send in 4 inputs, and what will I get out? All of those results. So these are the 3 output values for the first input, the second input, the third, the fourth. So this is how the predict function works. So I can create a model and I can start predictions. Now, they're useless and pointless and random without me actually training that model. So that's what I need to do next. Fit. So let's now create a scenario where we have some training data, right? This is my, and by the way, there is this really important piece of working with machine learning where you have both training data, testing data, you can even have something called validation data, and then you have the new data, the stuff that you're making guesses and predictions with. So I'm not getting that far into it yet, but let's just, in this case, I'm just gonna have some training data. I'm not gonna have any testing data, although we'll see. I mean, we're going to look at fit. We're going to see how this all works. Fit, here we go. So now I want to look at fit. So here, oh, look at this. Await, 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 await. I just made some video tutorials about await. So one of the reasons why, so working with TensorFlow.js natively, you're going to feel somewhat comfortable with the idea of a JavaScript promise and these new ES8 keywords, await and async. So I'm going to use those concepts. You might want to check my promises playlist if that's new to you. Okay, so let's figure out how we're going to do this. So model.fit. The parameters are x's, x and y. So here's the thing. Unlike here, and I really should call these x's, and this is really the y's, right? This is really what I'm doing. These are the x's, and now I'm getting the y's. To fit, I want to do the same thing. The difference is I'm going to have some known outputs. So in this case, I might have, like, this is my training data. These are the x's, and now the y's are, I need to make, presumably this would come from a spreadsheet or some type of actual database that I've thoughtfully thought about how to collect and the data and what I'm doing with it. But right now I'm just making up dummy data. So each one of these, I probably should just put in random numbers, but I'm like weirdly sort of lazy about this. I like you to sort of see it. So let's just pretend my training data set just has, instead of 4, let's just have 3 things in it. And let's, Let's just make some arbitrary. OK, so this is now my training data. I have the x's, right? The x's are, there are only 2 of them. Again, if I were doing my image classification example that I did previously with the toy neural network library, I might have 784 inputs for 784 pixels. But here in my made-up scenario, there's 2 inputs and there's 3 outputs. So the x's have 2 and the y's have 3. And you can see that reflected here. So now I should be saying model.fit the x's and the y's. Let's look here. Now, here's the thing. There's this variable called history. That's kind of interesting. So let's say const history equals model.fit. And I got to get into the weight and all that in a second. So what the history is that's an object that's returned that has lots of information about how the training is going. Like how accurate are things? What happened there? If I want to start looking at the properties of the training, what's the current loss? That type of thing. Oh, right, these mismatch. Thank you. So I was trying to simplify 3 and 3. These have to match. Thank you to the chat for mentioning that to me. OK. So then I have this idea of batch size. So batch size is, let's look at that, number of samples per gradient update. If unspecified, it will default to 32. So this has to do with the inner workings of how the gradient descent algorithm works, right? At some point, gradient descent is going to look at the error and is going to make all these adjustments to the weights. And so does it do that? Does it do that after 10 data points, after 20, after 32? So I'm going to ignore that. And then epochs or epochs, or I could never know how to know how to pronounce that word, is the number of times to iterate over the training data arrays. It's optional. I think the default is 1. So here's the thing. I'm actually just going to let this go without setting any of those. Those things are going to be certainly important, hopefully as I get into future examples or as you have specific scenarios. But basically, I could add an object here that has things like, that has various configuration properties, and this would need to be a comma here. But I'm going to skip that right now because I believe, according to the documentation, config is completely optional. So let's just run this, and then I'm going to have to start talking about the asynchronous nature of this. All right. What happens if I say console.log history? Let's just look at that. So look at that. I got a promise. Oh, it's promising me something. So what this means is fit is a function that executes asynchronously. Now it's possible I can do things with a kind of older style of JavaScript using callbacks, because it looks like in the documentation here, one of the options I can specify is a callback, but I'm going to use promises. So what I'm going to do is I'm going to say model.fit, then, and what I want to look at is, I don't know what, I'm going to just sort of see. And in this case, I think actually, the way that I'm doing it, I'm going to look at what's sent into the promise. So this should be a way, if it returns a promise, I can figure out, I can get the result of what it's done as an argument to a function that's executed when the promise is resolved. So this is how this could look, just to look at that history. And you'll want to look at my promises videos if this syntax doesn't make sense to you. And we can see here, looks like, I have a history object and I have a loss. There we go. So this is actually the response. And what I want to look at is the response.history .loss index 0. So looking at this, there we go. Now what happens if I give it a lot of, now what happens if I start to add in a configuration? Because I'm really curious, what happens if I say, so let me actually use a variable, I'm just going to call it config, And I'm going to say, two things I want to add is I want to say verbose is true, and I want to say epochs is 5. So because I want to see if it's verbose, am I going to get a lot of stuff in the console that's going to tell me about what's going on. So I want to add in some of those parameters. Verbose mode is not implemented yet. Oh, okay. So I guess I can't use verbose mode, but I can add 5. And so this is just the loss after 5. Let's add 100. 0.2. Negative 0.2. All right, actually, something weird was bothering me there for a second, which is why do I have a negative loss? Like, you can't have a negative mean squared error, right? Mean squared error has to be positive. It's the difference squared averaged over all the data points. So I forgot that I still had cosine distance. So let me put it back to mean squared error. And now we can see that I'm getting something that looks like it could be mean squared error, yes. So one thing about this, okay, so I'm going to get rid of this config. But what I really want to do is I want to see the loss values over time. Like as I'm fitting the model, I'm running the training data in multiple times. Maybe I'm shuffling the order. There's all sorts of things that I've done in previous videos that I want to do with TensorFlow.js. So how do I have this model.fit multiple times? I mean, I could just call it twice, right? Ooh, it did not like that. Whoa, oh, fascinating. So I can't do that. I don't know what's wrong with that, but that's not really what I want to do anyway. I could try to add a loop. By the way, the chat is really upset that I have these extra commas here, so I'm going to remove them. JavaScript doesn't care. It's like, put your commas wherever you want. Like, add a lot of commas, right? Oh, no, it doesn't want extra commas because it has blank entries. But okay, so what if I were to put a loop here? Say like, oh, I want to do this 2 times. So I want to fit the model twice. Again, I got an error. Ooh, it really doesn't like this. So here's the thing. I'm not exactly sure what this error is, but maybe somebody will tell me in the comments, but I was going down a road I didn't want to go down. This is where using, wherever it was here in the TensorFlow.js, the await keyword is crucial. So what I want to be able to do is I want to be able to call this fit inside a loop, but promises, just like everything's happening asynchronously, it becomes very hard to follow. So actually, what I really want to do is I want to go back to that syntax of saying const history equals model.fit, and then this is what I want to do. I want to say then console.log history loss. Okay? This is what I want. This is like synchronous code, blocking code. This is what I want. I want to fit the model and then see the results. It won't do this because that's not how JavaScript works. It works asynchronously. So there is the await keyword, which is new in ES8, which says, hey, wait for this and then do the next line of code. Right? Shouldn't that work? Whoops. And await is only valid in an async function. So again, if you watch my async and await tutorials, you would know this, but I cannot just do this anywhere in my code. I have to create a function with the keyword async. I'm going to call it train, and I have to do this inside that. So this is now the correct syntax. This actually is valid, but it's in an asynchronous function. I have to call that function. So I could just call train. Let's just run this now. And ooh, cannot read property 0 of undefined in train. So what do I have wrong? Let's put the x's and y's in that function. Oh, that's not the problem. History. Oh, hold on. Let's just look at the history. Oh yeah, it's there. History. Oh, dot history. Right. I keep forgetting. This is the response. So it was fine actually. History dot loss index 0. So I just want to look at just the loss. So these don't need to be in here. I don't want these in here. So now we run this again. There's the loss. Now, here's the thing. I'm just going to put a then in here because I also want to have some sort of event for when the training is complete. So this function now kind of magically returns a promise because of the way that await and async work. So I want to make sure this is working. Great. And now training is complete. Now guess what? I can now do this. I can do this 10 times. So I can now, the loop can go in here because of the beauty of this await syntax. This is now work functions as if it's blocking code. When it's all complete, it will return a promise. There we go. And we can see this is what we should have. The loss should be going down, right? Let's change that learning rate. Somewhere I set up a learning rate. Let's make the learning rate 0.5. You can see the loss is going down. And maybe, let's go back to point 1. Let's give it like 1,000, basically 1,000 iterations. And we can see the loss is going down over time. So, and now what I could do, 1,000 is a lot. The training is now complete. Now what I could do is I can call, remember this, I can now call predict. Now again, I'm only working with one data set. My training data is my testing data, is my validation data, is my regular data that I'm using in the future once I'm done training the model. So, but we now see the full process. I have X's and Y's. I can call model.fit. And again, this is really hairy stuff, not for the faint of heart. I'm in the weeds of the sort of like lower level TensorFlow.js stuff. Even though I'm in the Layers API, but using ES8 syntax. But now we should be able to see. Let's take a look at, I'm going to have an issue here where I have these Y's. So I'm going to call this outputs. So let's take a look. Let's train it just 100 times. Whoops. Oh, whoa. Silly me. Look what happened. So I totally forgot about the asynchronous nature of all this stuff. And I got the predictions before the training finished, right? Because this is happening asynchronously, which means what I want to do is after the training is complete, then I want to do my prediction. So I want to train using the asynchronous training 100 times. Then I want to do my prediction. All right, so this is running. We can see that the loss is going down. It's training over time. And when it gets to the end, I've got the results of my predictions. Now, you can see these don't look very good. Like, first of all, these don't resemble these outputs at all. The main issue here is that nothing here makes sense. I just have the skeleton of the story of data. I can create the model, I can fit it with some data, and I can ask it to run a prediction with that same data. But I'm ignoring like really important considerations, and you can see that machine learning is just magic. It doesn't just do the right, I don't get the right answer. So let me at least, before I go, add a couple things so that we can actually see that it got somewhere. So one thing that I want to do is I'm going to just simplify what's going on here. I'm going to make this data something really obvious, like 0, 0, 1, 1, 0.5, 0.5. That's my x's. And then my y's, I want to get 1. I'm going to just change that to just one output, 0.5 and 0. Whoops. What did I miss here? Yeah. Oh boy. Syntax, there we go. So what I'm doing here is I'm just trying to like come up with some ridiculous scheme that's like super simple to learn. Like there's sort of like an inverse linear relationship here. 0 goes to 1, it's like the map. Basically, let's see if this neural network can learn the map function. But I don't know why I'm using 2 numbers and 1 numbers here, but whatever. So now I am going to, I have to change the output to have just one output. And now let me run this. So we can see, look at this, the loss function is still pretty high. So there is something that's kind of important here. You can see it's going down, and actually after like 1,000 iterations, it kind of got something pretty close. So I would just need to give it more time to train to kind of reproduce the known results. But I just want to show a couple important things here. One thing that's important is I should always shuffle the training data. So there is actually a kind of important, one of the configuration parameters here for the fit function. Like if I shuffle is true, what this will do is whatever the x's and y's are, each time it puts it through the training function, it'll do it in a different order. And this will really help things as you're training with the same data over and over and over again. So let me add that in and just see what happens there. So I'm going to add this config here to here. So this is shuffle true. This is the only thing I've turned on. I'm doing one epoch at a time still. So let's also, while I'm here, just to make things go a little faster, let's do like 10 epochs at a time. Once again, total here, 1,000 times 10 is 10,000 epochs, right? But because I want to see it over time, I'm not just doing this once with the number 10,000 there. I'm doing it 1,000 times with 10. But this I think will make things move a little faster. And we can see I got even better here. And so now we can see this over time. We can see that the loss is really going quite far down. Now I'm gonna have to sit here and wait for a minute, which I'm gonna do, but you're not gonna have to. This video will now speed up. All right, I'm back. So look at this. I reproduced those results, right? I reproduced the same results that my training data should have produced, and I got the loss down pretty low. So you can, again, completely meaningless, trivial, nonsense, nothing, but hopefully this is helpful to you. It's helpful to me because I'm trying to figure out just how the library actually works itself. So let's review for a second. Okay, let's review everything. I have shown you now in these two videos that I can create an empty model, right? The diagram of my neural network architecture is an empty model. Then what I can do is I can create layers. There can be dense layers or other kinds of layers that I might look at in another time in the future, and I can add them. The order that I add them is very important because it is a feed-forward sequential model. So this is first and this is second. These, I'm thinking of this as hidden and output, but they're really just layer one, layer two. Okay. Once I've done that, I have to define what sort of mathematics are going to be used to train the model. And there's a loss function, mean squared error is what I'm choosing to use, and an optimization function, stochastic gradient descent, with a learning rate of 0.1. That's everything from part one. And now what I've done here is I've shown you, okay, if I have some data, presumably coming in from a spreadsheet, I turn those into tensors, I can use the fit function to train the model. I can say fit all of the weights with these x's and these y's. Once that's complete, I can then ask it to predict with presumably new data. This skeleton has not used any meaningful data. I'm also not really being thoughtful about what activation function makes sense or what optimization function makes sense. Different things work for different scenarios. So hopefully we'll see that more in the future as I make more videos. I would encourage you to just try to do this maybe with some actual data, play around with it, try different input shapes, activation functions, play around with it a little bit, see what you get. Let me know about those results in the comments. Let me know if this was helpful to you, and I will see you next video. I'm gonna look at that XOR problem again in the context of TensorFlow.js, okay? Goodbye.